So in the previous video or lecture, what we did or what I did was discuss the basic concepts, or rather the fundamental concepts you guys need to know before you start the course. Now in today's lecture, we're gonna discuss the beginning and the most fundamental concept, or well, topic of the course and the theory in general. And I'm gonna need you guys to know about topology and set theory, of course, as well as some vector algebra, linear algebra, of course, and abstract algebra as well. Maybe just in the previous, I suggest you guys check out the previous video and the introduction video, so you guys know which subjects you guys need to know in order to understand this course. Now, of course, the most fundamental or the most important subject is linear algebra, because we're going to be using linear transforms, and we're going to be working with vector spaces most of the time, or their products, or products of vector spaces. And yeah, also topology. And so yeah, we're going to use the topology when we define our system. Alright, so position states. What are they? So, in quantum mechanics, we study. Alright, let me fix. So, in quantum mechanics, we study subatomic particles and their behaviors through complex numbers and some form of advanced mathematics. But it ultimately boils down to the concept of the state, which is what's called a quantum state. Quantum state, which is mostly denoted by a ket of psi. I know you guys already seen this notation in the previous video, and this is just basically. And also in my biology course, you guys have already encountered this. And this is a function, which is the spin up state, times alpha plus the spin side state, beta, where alpha and beta are elements of the complex numbers. And this function satisfies, or it has to be that alpha and beta, these two complex value functions, must satisfy Schrodinger's equation, which is E times the state is equal to H bar, H hat, times that state. Wherein H bar is the Hamiltonian operator, which is minus I H bar over 2m. Yeah, minus I H bar over 2m. Oh no, H bar squared. H bar squared. Yeah, I H bar squared times the Laplacian squared plus a certain velocity function v of x c. Wherein this Laplacian is what I stated in the previous video to be, what we want to do is take the dot product between the Laplacian and our given state, where our Laplacian squared times the dot product, or the Laplacian squared is basically just the sum of all second partial derivatives, or the second total derivative of our quantum state. So this times our quantum state psi gives us d squared over dx psi plus d squared over dy squared times psi plus d squared over dz squared of psi. Okay, so enough about quantum mechanics. And these guys, this states are denoted or rather encoded in a special complex value function, which is psi that I said a while ago. But here is where we take a turn in position theory, because the three main gender states, or the three main position states, top, bottom, and switch, are not complex valued functions. These are not complex valued functions, and they do not encode some state that pertains to a quantum system. Rather, these guys are labels or metrics for a certain region of a given space that we're working with. So, before I discuss P, B, and S, or these three main position states, we need to first talk about the product or identification. So, what exactly do people, what is the system that we're working with exactly? Now, when we talk about orientation, sexual preference, and, well, look of a person, we could say, or rather appearance, well, as I stated, it's the product between O and math cal P. This is not rho. Rho is written. I'll write rho like this. Okay. This is P, and then we want to take its. I discussed this in a previous video in the building intuition, and this just basically this gives us a topological space, and we have their topology, and then P close. So it's our topology in this. This is what we're working with. We're in this T is the indiscrete topology. So we're noise in the background. This indiscrete topology of the set O by math cal P. Okay, I'm sorry for the noise in the background. So now I stated in the previous video that we're working with an indiscrete topology because a discrete topology is simple and it's rather boring. In fact, I want to say or define the topology on this product. It's defined T of O by P to be basically the collection, the empty set with empty set equipped with our given product. Or rather, this is a collection, so we're using brackets. This is not interval or in equipping. Alright, so what do we do then? What do we do with this space? What is this O and what is this P? These two are sets. When we want to say sets, they work the same way as the real numbers are. These guys, O and math cal P work the same way as R, which is our Euclidean space, or real numbers product with itself n amount of times. And so, alright, so what is O and what is P to be precisely? What sets are these guys, or what do they define? Well, as I stated in the previous video, or maybe I didn't state it, but I want to state it now. Alright, so now let's make a definition. Definition. O is the set of all sexual orientations. Sexual orientations, which I will denote X sub I in J in index set. So I'll say this is definition 1. So O is the set of all sexual orientations, X in I in J in index set. So So to make it more precise, to make this definition more precise, we can define X to be an element. Alright, so first let's define a language. What's a language? Alright, what's a language? So I'll say this is definition 2. Definition 2. A language, I'll say it is a Macal-L, is the clean star operation. Is the clean star operation over a set of letters in the literal sense. In the literal sense. Okay. So we'll let this alphabet, so set a set of letters, which is an alphabet. And I'll use the A in the previous video to denote this alphabet. So I'll denote the alphabet as A, and the clean star operation over a set, which I will say, let's have a set X. A clean star operation, which is denoted by this asterisk, is basically all words we can form out of the elements of X. So when I say words, that means combinations or strings of these guys. The set of all words formed from elements of X. And again, when I say word, that means just combinations or strings of these guys. So let's suppose A here is composed of the letters A, B, and C. The clean star operation of A. Okay, I want to say this is finite, so we don't want to run into infinite words like a dot dot dot. So the clean star operation on this A is, well, first let's go with just A, and then A, and then A, and then dot dot dot, finite amount of times, and then it starts with B, 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 and then dot dot dot, and then C, 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 dot dot dot, and then A, A, B, A, C, and then, you know, on and on. Anything, any word you can think of, any expression you can think of that's formed with these three letters, all finite versions of those guys put into a set is the clean star operation on A. So if we have the entire English alphabet, all 26 letters of the English alphabet, disregarding lowercase, uppercase letters, we just assume that it's uppercase letters. So if we let A equals A, B, C, and then dot dot dot, X, Y, and Z, then the clean star operation on A is the entire English language. So from there, we define our Macal-L to be equal to the clean star operation on A, which is the entire English language. Any word you can think of is part of this set, such as the word bed. Note that this set is not equivalent to its inverse, which is B, B, B. So again, this stuff is non-commutative. So if you were to form a group on A with respect to the clean star operation, it's not abelian or not commutative. Alright, so BEB, BED not the same. Alright, so it's not commutative. It's the order matters basically. Alright, so L is equal to A star, which star is the clean star operation. So any word you can think of, bed, femboy, boy, boys, it's all in this set. Alright? And what we want to do with this set A star, which is math cal L, is we're gonna say that a word or an element from this set L is a word from the English alphabet. And so what we want to say is that if you remember our first definition a while ago with P sub X sub I, now we'll say that X sub I is an element of L. Now we have a very rigorous definition of what, or precise definition of what exactly we're saying. So L is our language. So L is our language with the element X sub I and J, which is all in all an element of O, right? Which is our orientation. So X sub I and J is an element of O of L, math cal L, such that it describes the sexual orientation of a person B. Normal P, not math cal P. Okay. So what we're saying here is that X sub I could be any word in the English alphabet, but just the words that describe the sexual orientation of a person. So this X sub I is mainly defined to be one of the following in this set. So X sub I can only be an element of this set, which is I'll say B, which is composed of words G-A-Y, B-I-S-E-X-U-A-L, S-T, R-A-I-G-H-T, P-A-N-S-E-X-U-A-L, and any other stuff you can think of. And note that these guys like G-A-Y is actually an element of our clean star operation a while ago. So this G-A-Y is an this G-A-Y is an element of our L, which is our clean star operation on math cal, which is our language, our English language that you guys know and love, and where these guys come from. Now we don't want to talk about it's not really in our interest as to study the origins of these words and why they come to, and why that matters when it comes to saying or discussing where these guys belong to and where we take them from. All right, that's independent. This entire theory and any other theory that I discuss in LOSC, I want to make perfectly clear, is an abstract thing, and it's all done for the sake of mathematical playfulness. I don't want you idiots to use this in a way where it dictates people's lives, okay? I don't want you to go around people and then telling them, oh, you should be like this, you should be like that, just because you saw my theory and thought, hey, isn't that what people think it is? I don't want this theory or any of my theories, including or especially person theory. I don't want any of those guys. I don't want any of my studies, any of my lectures, or whatever I discuss about here to be used as a thing against other people. Do not use my lectures, do not use my lessons, or do not use my concepts as a way to gatekeep things or spread negativity. Alright? I want to make that perfectly clear. Because when I discussed with a bunch of people about my Stephenson-Maxwell paradox, people already thought that I was transphobic just because I came up with the result. that abstract result that has nothing to do with real life was perceived as an attack. So I don't want you guys saying any negatively things. Do not gatekeep using my theory. Just because it makes sense through logic does not mean that this is the definitive gospel you guys should follow. Okay? I want to make that perfectly clear. I feel very pissed. I would feel very pissed if one of you guys used my theories to combat people in the community. I don't want you guys to divide the community just because logic said so, or this thing, this system I built up said so, or this theory that I made up said so. Okay, this is not the end all be all LGBTQ community guide. All right, enough with the rant. Going back to the lesson. All right, so now we've defined O. Let's use this definition or these two definitions, definition 2 and definition 1. To define an element of P, mathcal P this time. And mathcal P now is appearance. We say appearance. So, like x sub I, we'll define a y sub I and j an index set. So, when we say it's index, now we're saying that it's a family of things. It's a collection of things. It's not just one thing. It's a bunch of other things. So all of this family is inside of mathcal P. And so to be, now we're going to define this y, I, j in P to be an element of the language L, which is equal to the clean star operation on A, with a, I'll recall, equal to the entire English alphabet, A, B, C, X, Y, Z. Now when if you have an instructor here, or when we start having, or when we have instructors, or when I instruct you, when it comes to doing this, I lost a bit. Okay, so when an instructor tells you, or when an instructor discusses this with you, and there is a letter that's missing, but we don't want from the letter, like let's say someone for some reason or for the sake of tearing down my theory makes up a sexuality that involves something like an enya. Like this. An enya. Say something like an enya or the say this O, this kind of O over here, or an in Nordic, which is like this, which is not the empty set. It's not empty set. I'm talking about in Norse. Now, if we have a sexuality or something that's an element of P or O that's composed of one of these letters or letters that are not part of this set A or mathcal A, well, I suppose you guys can just sort of use context clues to say what it is or describe it. Just describe it in your definition. So when you define it and make the construction, just sort of say that it has that. Or let's just assume in the beginning that your A contains that certain certain letter inside it, okay? So yeah, more clarification. Okay, so now we define this to be a type of appearance. So y can either be, alright, yi is an element of the set B, which is now, it's not the same as a while ago, but now it can be F-E-M-I-N-I, feminine N-E, or M-A-S-C-U-L-I-N-E, or A-N-D-R-O-G-Y-N-O-U-S. So feminine, masculine, or androgynous, right? And so, as that. So Y can be either one of these three words, mostly. Now there can be other ways of describing appearance. Say someone's feminine, someone's masculine. Now, I don't want to say that feminine and masculine are intrinsically female and male things, but they are what they are. When you say feminine, it's mostly concerned with apparel that's more free, I suppose, and more exposing. I wouldn't say that. It's not. Don't take what I say as gospel, but that's how I like to think about it, at least. So, the liberals out there, please don't attack me. I'm a neutral after all. And so, yeah, masculine is something that's it's strong, it's rugged, it's robust. And androgynous, it could be in the middle, like a gray line. Like how white and black are not what life is composed of. There is a gray, after all, a gray area where things are not simple. So, yeah, one of these three. And so now, when we start working with vectors and this vector space, which is O by P, we define a metric now. So it's not only a regular topological space, but now O by P is a metrizable space because we have a metric or a mu bar that assigns regions of this guy, of this entire thing, onto the states, onto the gender position states. I keep saying gender states, position states. So again, keep in mind. Now, remember that O by P by T, O by P is what we're working with. This is the space we're working with, and it's the product between O and P. I'll rewrite that. O by P. O by math cal P. And then T, O by math cal P. That's what we're working with. And now you can think of this as an axis. Now, when you define your axis and when you define our two axes, now it's really dependent on the preference of the instructor or your situation. If you want the positive region to be masculine and dominant, or they are dominant, and then negative to be feminine submissive. So I'm a bit wrong a while ago when I said that P was appearance. P can be position or the dynamic of the person. So I'm just gonna rewrite that definition and say it's alright, so definition 3. So now this is the real definition of it. I was confused a bit a while ago. Y is an I element of math cal P is a dynamic. Yi is an element of course, our language, which is the Twin Star operation. And that's that. And it's dynamic. It describes, it's not really position. Elements of P are not really position, but rather they tell us the behavior of our specimen or our person. So submissive or dominant. So we say that Y sub I is an element of this set B, which contains D-O-M-I N-A-N-T or S-U-B-M-I-S-S-I-V-E. So you can either be one of these guys. And when we define the switch position, it would be any set or any point that contains both of these guys. So it's a union of the dominant submissive and masculine and feminine, or it could be just one of those. It really depends on your situation. Alright, now that I've redefined definition 3, alright, let's go and discuss about the space that we're working with now, which is O by P. Math cal P, of course. Equipped with its topology. Okay. So now think of this as an axis that runs that's Y and X, and this would be O and this would be P. Now again, these guys are interchangeable. This can be O and this can be P, but just for me, I'm gonna do it like this, okay? So now there are these regions. So extremes and these guys or polar opposites will define what exactly our things are. So in our P, I'm gonna define this region here, where this is O. I'm gonna say this is O, and onto positive infinity here in the P direction. So I'll define positive infinity P to be positive infinity on the P direction. And so I'll now say that the interval 0, not included of course, 0 included to positive infinity P, not count P, of course not included, is the interval of dominance. And it's this entire array. So it's array really, it's not an interval. Stretches onto the array. And then so now I'll define this over here, this interval, to be 0 included onto minus infinity, which I'll define to be the interval of submissiveness. Interval of submissiveness. And then now I'll define 0 up to O infinity. Well, O infinity is just infinity in this direction. I'll define this now. So I'll define the interval, so interval 0 up to infinity or positive infinity O. Of course, 0 is included. Interval of masculinity. I'm sorry. This is actually supposed to be P now. So disregard what I said a while ago about me preferring. So this is actually going to be O now. Oh no, your preference. So it's it's correct. It's correct. O is the appearance, and the P is the dynamic. Okay. Interval of masculinity. And then now, this interval from 0 onto minus infinity O, so 0 included, minus infinity O, the interval of femininity. And then so we have a point here, so we have an example point here, P, and then that P now, I will say, is the coordinate, it steps here, so it's dominant, and then here is feminine. So we have a femboy or a femboy or something like that, that's dominant, right? So yeah. Now you're asking me, okay, what does this have to do with P, S, and E, and the B positions on the states? Now, since I said a while ago that this space is metrizable, that means we can define a metric D that maps 2 points from here. So x by y. So that is fixed onto a metric. So onto a state T, S, or B. So as I said in the building intuitions episode, these three are not exactly vectors, but rather they are metrics or things that we map stuff here onto. So given a person now, or D, which is actually defined to be mu bar, is a function that maps or tells us degree of gayness. We can now use mu bar in a more general way and say that it's a map between this space and this space over here, which we will call the position state space. So PS state space. PS space. Find this as the PS space, or the position state space. And now mu bar maps 2 points from these two guys or I'll say in general that V bar maps the product O by mathcal P onto this PS space, which is top, bottom, and switch. And now what we want to do is define this function. So this is a function now as a piecewise function. And that piecewise function is T for well, dominant and masculine, I'd like to say, because we know that daddies are actually strong, masculine, and they are dominant in bed, right? So we'll define this as the interval a while ago, which is 0 to O infinity cross 0 up to P infinity. So 0 infinite positive infinity B, yeah, cross, and then 0 positive infinity O. Please correct me if I'm wrong here, alright? And then the next one, switch, will define to be all, product of any. So it contains, it's either any of these guys. It can be O, it can be P cross O, plus infinity O, or union, I'd say, union O plus minus infinity P cross O minus infinity O. There. So that's for this, and then now the last one is the bottom state. We know soft, cuddly, submissive femboys are feminine and submissive. So now it's the minus now. So this is 0 minus infinity P X, or cross 0 and minus infinity O. So that's our piecewise function, and we're saying that if a person lies within this interval and this interval, so if our specimen lies within this interval in the P direction or in the dynamic direction, and it lies within this interval, and it in its second coordinate, which is the O, the direction we take in the O direction is part of this interval, we're saying it's a top. And then the same thing with the switch. So switch is a bit ambiguous because they can either be tops or bottoms, so I would say union. So they can fall in any of these intervals. Now we can say that the top is a switch, we can say that the bottom is a switch, because switches can be either of these two guys. So I'm saying the union. So it can fall in any region, and then say you can say that it's a switch though. But then this implies that T and B can be switches as well. T and B are switches because they fall within this interval. And that's because that's what switches can be. They can be T and B. So that's why they both fall in this interval here, or these two intervals. So actually we can define as, now we can replace, instead of a union, or instead of separate products between unions, we can now just define it as minus infinity and then positive infinity. So you can now define this as minus infinity O, minus infinity positive infinity O, cross minus infinity P, positive infinity P. There. So any vector or person that falls within this interval is a switch. And then lastly, the bottom, of course, if they fall within the minus parts here, as I defined a while ago to be submissiveness and feminine, they are assigned this here. Because community is so keen on labeling things, we now define this over here. And actually that's actually all I have to discuss about these states over here. They're not exactly vectors themselves as stated or as implied in quantum mechanics, but rather they are metrics or things that a certain person is mapped on. So long as the attributes of the person lies within a defined interval. Now I say, I need to make this importantly clear or abundantly clear that it depends on your situation, okay? What I said here is not a final thing. You can pick any basis actually. You can say that this axis is actually the O axis and this is the P axis, and then you can define the intervals in a different way. But what I just said is just an example, just one case. This can actually be the the positive one, I'll say for example that this interval can actually be, this one can actually be submissive, and then this one can be dominant, interval of submissiveness. And then I can define this one here as 0 minus infinity b interval of dominance. I can define it. You guys can do that too. It really depends on you guys and your instructor or your situation. So that's it for this lecture. So for the next lecture, now what we want to do is think of positions in specific ways. So positions as either vector spaces or as sets of characteristics. Now here, we're dealing with something that's akin to the Euclidean space, and it's not really a vector space. But the next lecture, we're gonna actually apply vectors now, and we're gonna see what we come up with mu bar and stuff like that. And so we're gonna be talking about vector space, not necessarily topological vector spaces, but vectors, and describing positions as well, their own vector space rather than its own set, right? So what we had a while ago was a space, and then now we just have a regular set of vectors. So we're not thinking of the positions now as only 3 of them, but we can think of new positions now as their own separate entity or mapping. So anyone can create a new type of position that's not top, bottom, or switch, which can be a composition of those guys. So top, bottom person, switch person, switch bottom, switch but mostly leaning towards submissive, switch but leaning more on top or dominant, and yeah, we define those as new position vectors that are linear combinations of our metrics, which is the main position states T, B, and S, which is dominant, submissive, and switch. Now, I know this topic wasn't inertly sexual. It's built on sexual topics actually, but what I want to do is have a little mathematical playfulness and define this in a rigorous mathematical way as a metric over a metrizable space, or metrizable topological space. And so, yeah, in the next video we're going to be talking about vector spaces, and yeah, and and also included there is we're gonna say that we're gonna define positions as sets of characteristics now. So we're gonna define positions as simply sets containing just the elements y and x. Y, I in our language L, or xi in our language L. You can just define a position T as a coalescence of one of these guys, or a collection of one of these guys. Of course, those guys are indexed by the index set. And so, yeah, that's it for this video, and I'll see you guys in the next one. Now, Monday's when I'm gonna record the next one, or maybe tomorrow, depends. And there's a chance that I'm gonna be discussing the next topic in my high school, or in my school. I'm not gonna say which school it is, but we're gonna discuss there, and it's gonna be a larger space. It's gonna be a larger whiteboard. This isn't actually a whiteboard. It's just a plane of glass. You guys are probably gonna see the entirety of me in a uniform. Or I'm gonna try to wear a jacket so you guys don't see the uniform of my school. So yeah, we can probably record it in my school and stuff like that. So yeah, that's it for this lecture, and I'll see you guys in the next one.